Hello friends, here we are going to see about the electrical properties of crystals or solid crystals. We know there are three types of crystals according to their conducting property. They are known as the conductors, semiconductors and insulators. These properties we can able to explain based upon one important theory which is known as the band theory. As per this band theory, atomic orbitals that are close in energy combine to form molecular orbital which are so close in energy to each other as to form a band. Atomic orbitals are combined to form a band. There are low energy molecular orbitals which we are called as the valence band, and empty unoccupied orbitals we are calling as the conduction band. So based upon the electrons are transferring from valence band into conduction band, when it is flowing easily, then that will be started to conduct. So when we are considering about the different types of what we can say crystals like conductor, semiconductor or insulators, the gap between valence band and conduction band is the main criteria. When there is no gap between valence band and the conduction band, then they are overlapped situation and electrons can able to easily escape or easily jump from valence band into conduction band. They are called as the conductors. Whereas if the gap between them is larger or it is not easy to jump from valence band to conduction band, then the electrons are not flowing and that become insulators. Whereas in case of semiconductors, there will be small energy gap will be there between valence band and conduction band. So normal temperature, the electrons can able to flow, but very few electrons can able to flow. That is why they are having low conductivity property compared to conductors. Whereas when the temperature is increasing, what will happen? Conductivity is increases because more electrons can able to jump from valence band into conduction band. This is the case of semiconductors. Next one. Doping of semiconductors. Usually semiconductors at the room temperature, I told you, they are having low conductivity, which we are called as the intrinsic semiconductors. When we are adding some external impurities, then their conductivity is going to increase. Then that we are calling as the doping of semiconductors, and we are getting extrinsic semiconductor. So doping semiconductors involves adding small amounts of other elements to them to increase or decrease the number of valence electrons in the orbits. There are two types of semiconductor by that way. One is N-type semiconductor and second one is P-type semiconductor. For example, in the case of silicon and germanium are the two examples which we usually used to take for considering about the semiconductor. So these silicon and germanium, they are coming under 14th group. So if we are doping phosphorus with silicon, what will happen? You have to just think about that. If the 13th group element is adding to this 14th group, then they are having one number of valence electron is less, then they will create a vacant hole. Whereas if 15th group elements are adding to 14th group, one valence electron will be excess, then there will be one uncombined free electron. These are the two basic conditions for N-type and P-type semiconductor. So here you see, when silicon is doped with the phosphorus, the valence electrons of the phosphorus atom enter orbitals in the conduction band. This bridges the gap between bands and allows for some electrons flow, thus increasing conductivity. This is known as N-type semiconductor because there are extra negative charge or electrons present, because phosphorus is coming under 15th group, so 5 valence electrons will be there, 4 will be combined with the silicon's 4 valence electron, but 1 will be extra, which will be a current carrier, thus they will increase the conductivity. So they are known as the N-type semiconductor. Whereas if gallium is added to silicon, that is coming in the 13th group, so silicon is doped with the gallium, some orbitals in the valence band are empty because they are not having enough number of valence electron, so which creates a positive hole. This positive hole is the another charge carrier, and thus their conductivity is increases, and such semiconductors are known as P-type semiconductor. So this N-type and P-type semiconductor is very important for you, because for the CBS examination they will give you like these two examples, and they will be asking you what is the nature of this semiconductor. So if you have to remember only one thing, if 13th group is doping to 14th group, you will get P-type. 15th group is doping to 14th group, you will get N-type semiconductor. Next is about the magnetic properties. So magnetic properties means there are different magnetism you have to remember. Anyway, last year in your class 11th, you have studied two types of magnetism. One is paramagnetism and second one is diamagnetism. In this chapter, you are going to see nearly 4 to 5 different type of magnetic properties. That means here actually similar to our solar system, our electrons also rotating and nucleus also rotating. They are having some magnetic nature and they are creating some magnetic moment. In this way, these are some important magnetism properties. Diamagnetic materials means very well they are completely paired electrons. So paired electrons means they are repelled if they are keeping in a magnetic field. Such materials are known as diamagnetic materials, and this property is shown only by those substances which contain fully filled orbitals. That means no unpaired electrons should be present. Example, titanium dioxide, sodium chloride, benzene, etc. They are coming under diamagnetic materials. Whereas in the case of paramagnetic materials means if they are keeping in a magnetic field, they will be attracted by a magnetic field, but they lose their magnetism in the absence of magnetic field. That means if you are removing the magnetic field, then they will lose the magnetic nature. That type of materials are known as the paramagnetic materials. You know very well, last year in the molecular orbital theory chapter, chemical bonding chapter, you are learned about that. For example, oxygen, they are having paramagnetic nature because they are having unpaired electrons in the antibonding orbital. So this property is shown by those substances whose atoms, ions or molecules contain unpaired electrons. These unpaired electrons are occupied, means they will be attracted by magnetic field. Such properties or such materials are known as the paramagnetic material, which are having attraction towards the magnetic field. And another type is known as the ferromagnetic substances. Ferromagnetic substances means show permanent magnetism. This is one of the important point you have to remember. Permanent magnetism even when the magnetic field is removed. That means they are also strongly attracted by the magnetic field. When the magnetic field you are removing, automatically their magnetism is not going to lose similar to paramagnetic material. They are maintaining their magnetic nature. That is known as the ferromagnetic substances. Example, FeO, CrO2, etc. The spontaneous alignment of magnetic moments due to unpaired electrons in the same direction give rise to ferromagnetism. That means when the magnetic field is applied, their magnetic moments are aligning in the same direction, not going to cancel each other. That means magnetic moment, you remember, they are having upward and downward arrow mark we are representing. So diamagnetism means you are having equal number of upward and downward arrow marks magnetic moments, so they will be cancelling each other. Paramagnetism means they are having unpaired one side arrow mark only, they will be attractive. Ferromagnetism means they are also having one side arrow mark, they will be maintaining their paramagnetism. That means they are having permanent magnets. So these are the material which are using for preparing permanent magnet also. Another type is antiferromagnetism. That means they possess zero net magnetic moment. Means it is opposite to ferromagnetic substances. Means if you are keeping in a magnetic field, they are having equal number of upward and downward alignment will be happening, and net magnetic moment becomes zero. That is known as the zero magnetic moment substance or antiferromagnetic substance. Example is manganese oxide. And next one is ferrimagnetic substances. They are having small net magnetic moment because if it is keeping in a magnetic field, some magnetic moments will be aligned in the upward direction, some will be aligned in the downward direction. That means unequal arrangement of magnetic moments. So some will be cancelling and some are not cancelling. That is why moments are aligned in parallel and anti-parallel direction in unequal numbers, resulting in a net dipole moment. Example, Fe3O4, ferrites of formula M2 plus Fe2O4, etc. These are coming under ferrimagnetic substances. So these are the different magnetic moments or magnetic substances coming under this chapter. Thank you.